One of the things we need to take a look at, and this will apply really to all three license levels, um, and we'll do this before we get into doing any videos on specific questions that are on the exam. We do need a little bit of background, and I'm going to make individual videos for that sort of thing. This one, we're going to talk about algebra. And that's a topic that a lot of people dislike or are afraid of, and it's completely understandable. So I want to talk just a little bit about that, see if I can move you past that particular point. And I'm going to do so by starting with kind of, well, first of all, what does algebra deal with? What's different from it than arithmetic? And the chief differences are that we are looking at equations, and we're asked to solve those equations, and we have the use of letters of the alphabet. Okay, so let's take a look at this idea of equations first. And you've actually been dealing with those even in arithmetic. So if I have some addition problem, let's say I have 12 plus 6, okay, and I give you that problem, you know what to do. We're in kind of a column format here. You're going to add the 2 and 6 and get 8, and you're going to bring down the 1 for a total of 18, and you know that you're adding because it has this symbol right here. Well, believe it or not, this is an equation. And to see it as such, let's write it out more horizontal, because typically in algebra we like to work horizontally because a lot of problems have more than one or two steps. So the column format doesn't work real well. So let's just write this out. 12 plus 6, and we've already done the work here. We know that that equals 18. This is an equation. And outside of being horizontal, the only other difference you might notice is that it has this little double bar, the equal sign. You've all seen that before. Okay, the equal sign over here is this line. In bookkeeping, for example, when you do totals, or at least grand totals, this is a double line, just like this is. But let's talk about, for a minute, exactly what it is that means. It means that what's on the left side of this equal sign is identical in quantity to what this side is. These two sides are equal. They're both saying the same thing. If you thought of this as pounds or dollars or whatever, if you add 12 and 6 together, you get 18, and 18 does indeed equal 18. That's an identity, but don't worry about what that means. Okay, the point is that this is an equation and it has an equal sign. That equal sign is all important. If you're dealing with a mathematical expression and it does not have an equal sign in it, then it is not an equation. And why that becomes important we'll get to either in this video or in the next one. Okay. The idea here, though, is equality. That's hence the term equal. You can think of it this way. This is the recipe that created this. That's a good way to find out about it. Now, what makes this different from arithmetic is what happens if we don't know one of the values. I'll just draw an empty box here. Well, we've already worked the arithmetic problem, so we have a pretty good idea that this value is going to be 6. But let's look at the algebraic process of finding out what this value is, because it's a very mechanical process. And the first and biggest rule is this. First of all, think of this as kind of a balance. And it's in balance. This side equals this side, even though we don't know what this is yet. We are allowed to add, subtract, multiply, divide, or any other array of math operations and numbers. We're allowed to apply those to the equation in such a way that it helps us determine what's the missing piece here, as long as we do not upset the fundamental balance. In other words, I can't add 3 to this side and not do something equal to this side. If I add 3 to this side, then I have to add 3 to this side. Otherwise, I'm changing the fundamental value. So we get to the golden rule of algebra. Whatever I do to one side, I must do to the other. Never forget that. Okay. There is a very mechanical process of finding out what this box is. But let's bring in our idea of letters. And the function of adding letters to this is that since algebra is a mechanical process, meaning that I am moving this term or this term or this term, and by moving I'm either adding, subtracting, multiplying, and dividing, and of course I have to do that to both sides. We are moving things around in this equation, and having an empty box here is not very convenient. So if I choose a letter like X, it doesn't matter what the letter is, at least at this point. Okay, and I write this down as 12 plus X. And I've had students say at this point, well, I don't understand that. I can add these numbers over here, I can do this all day long, but I don't know how to add X to 12 and get any kind of a meaningful idea. It just doesn't compute. And you're absolutely right. It doesn't. We're not going to add this letter to this 12. This X is like being on a movie studio and they're setting up a movie shot. And believe me, there's a lot of setup in getting the cameras right and the focus set and the lighting lit and whatever. And instead of putting the actor through all that while they set up, they'll use just some warm body there, and they're called a stand-in. That's all this X is. This X is standing in place of a value yet to be determined. And it's put here so that we have something to move around. Without it, we would not be able to manipulate this equation. And what we are going to do is we are going to apply either adding, subtracting, multiplying, and dividing, or possibly numbers or whatever, till we get down to a point in the steps where we get X equals, and there's some value here. When we get to this step right here, we have solved the equation. It tells us the number that X is standing in for. Now we have a pretty good idea that it's going to be 6 because we've worked this, and you don't need any algebra to understand some addition facts here since this is a pretty simple problem. I can get 18 if I add 6 to 12. Okay. So let's take a look then at what we do. And the process, mechanically, is pretty simple. Let's put our X back in here. And this brings us to the next big point. And that is one of the things that baffles students in algebra. They'll see an equation like this, and they say, well, I don't know where to start. Over here, there was no answer here. I knew to add the 2 and the 6 and bring down the 1 and get an answer. Here, I don't know what to do. I can't add X to 6 and get any kind of a meaningful answer. And that's true. So in any equation, the key to where to start is to put your focus on the x, or whatever the variable happens to be. That's always the first step. Find the variable in the equation. And then you want to look at it and think to yourself, or say to yourself, what's being done to this x? Well, it's being added to 12, or since order in addition doesn't make any difference, you could say that 12 is being added to x. Okay, well, alright, that gives us a little clue. You said that we could do any math operation we want as long as we do it to both sides of the equation. If I'm adding 12 to x, I can see that if I subtracted 12, and of course I have to subtract it over here too, 12 from 12 leaves 0, and we're left with just the x, and 12 from 18 gives 6. And I'll get rid of that 0 so we're not confused. I'll write that down. Well, look, in basically one step here, we got to the answer, and we didn't do it by guessing or using our addition facts. We used the mechanics of algebra by undoing whatever this math operation is. That's really what you're doing. When you're solving an equation, you're taking it apart and undoing the math operations that are being done to the variable until you finally get down to the step where x is equal to a value. Alright, I forgot to set my timer on this, and I'm sure I'm over 10 minutes. I like to keep these at 10 minutes, but that's okay. I don't want to break our concentration on this first video. So we'll pause here before we go into the next video, and let me go back and just say again, the important takeaway here is don't be freaked out by letters. They're just stand-ins, and they're necessary because we're going to be adding, subtracting, and multiplying to move these other values around until we get to this step. This is the answer step. When we finally get x by itself, it's isolated by itself, and it's equal to some number, this is solved. Okay, so this is where practice is worth 1,000 words. Okay, I'm going to stop here, and we'll pick up here in the next video.